I love titanium. It's sleek, it's beautiful metal, it's strong, it is highly corrosion resistant, it can handle high temperatures. It's just like a wonder metal to me.
The ultimate goal really is to make titanium cheaper. Titanium's really abundant in the Earth's crust, so what we're really hoping to change is that titanium will be more usable and widely available.
People would use it more if they could. I believe that it's the right time to bring it into mainstream.
Here at IperionX, we're ushering in an age of titanium.
Right now, the titanium is made by the Kroll process. It's a batch process, high energy, high temperatures. It's a long-term process. They have to go through a chlorination process initially, which chlorine's a pretty nasty material to work with, very corrosive. And we are bypassing all of that.
We need to produce titanium with lower oxygen content. So deoxygenation process is trying to refine the titanium metal to obtain the titanium metal with a very low oxygen content. So if we can convert titanium oxide directly to titanium metal, bypass chlorination process, we should have an advantage in terms of the energy efficiency, in terms of the cost. We've come up with this new process we call a HAMR process. It's a hydrogen-assisted magnesiothermic reduction process. It really can produce titanium metal at a significantly lower cost than the conventional Kroll process.
Basically, we're doing a direct reduction, and we're doing it at low temperatures. In our case, our processing approach is very simple, very straightforward. We are producing a powder, and we have a lot of flexibility in how we use that powder.
The GSD process is a new process we developed to make spherical titanium powder for 3D printing. We basically start with very fine particles. The particle fuse together to get spherical powder for additive manufacturing.
Or if we take it straight into bar or wire or plate, this is a very scalable process. We can make powder cheaper of the current primary titanium sponge that's available. So we'll have a US supply chain. That's one thing that's very critical right now. We're missing a US supply chain. We have several thousand acres of mineral deposit already secured in Western Tennessee. So we will be able to take from the ground in Western Tennessee all the way to a final part.
The process here on site for sample collection is rotosonic drilling. A sonic vibration is sent down the drill string in order to cut the material or loosen it up for extraction. That sample is pulled out in 10-foot intervals. It is sampled on 5-foot intervals. A portion of that is collected and sent off to lab for analysis.
We'll be collecting that material and we'll go through a gravity separation, water and gravity, just using spirals to separate out the high density and low density materials. And then we'll go through magnetic separation. Again, low energy, low impact to the environment. Take that material and that comes into our HAMR process.
Introducing the HAMR process by IperionX, developed by world-renowned metallurgist Dr. Zach Fong. HAMR is a patented powder metallurgy process technology that allows for the production of angular or spherical titanium powders. This process can take almost any form of titanium or scrap titanium alloy feedstock and produce spherical or angular titanium powders at lower energy, lower cost, in a sustainable closed loop. We take these high-oxygen titanium powders and feed them through our HAMR process technology, which removes nearly all the oxygen to levels that are even lower than industry requirements. After HAMR is complete, we run the powders through conventional post-processing. The powders are then rigorously tested to ensure they meet all applicable industry and customer specifications. IperionX is one of the only companies in the world that can take 100% scrap titanium metal and transform it into an inexpensive, sustainable, and high-quality spherical titanium metal powder. Our titanium metal powders can be used with either powder metallurgy or additive manufacturing technologies to make critical components for a wide range of industries, including automotive, consumer, industrial, aerospace, and medical applications.
It's really one of the most unique processes that have been brought to the titanium industry in the last 50 years.
Now we've got an excellent source that we're not having to ship around the world. We are refining it right there. It's titanium metal, and then we're taking that right to final part. It was done in America with the next generation of technology that really ought to be spread to the rest of the world.
This technology is so exciting because it gives us the opportunity to really shake up the titanium industry, optimize the process, lower cost of our process, and so then you can start seeing titanium products where you'd normally see stainless steel.
It's just really fun being a part of something that is growing and continually trying to change the market.
There's an opportunity with the technology that we have, make North America and the US a leader in the production of titanium. We can have titanium used in these applications which will improve electric vehicles, our commercial aerospace sector, advanced consumer electronics, space exploration. It's amazing.
I think it's going to revolutionize the titanium industry.
We can actually change the world by bringing about an age of titanium.